Okay, this is number 31 on lesson 2.2, and they give you this kind of crazy equation here. It's a rational function, meaning that there's variables in the denominator. Find the end behavior model. In other words, what's happening at the right end and the left end of this graph. And if you know how to do end behavior models, it's not that tough. The highest exponent drives the car. So it controls the graph. So we see up here we have a 2x to the fourth. On the bottom, our highest exponent would be minus 1x to the first. So our end behavior model is going to look like this. 2x to the fourth over negative 1x to the first. So you look at the highest exponent's term in the numerator and denominator, and then you simplify. 2 divided by negative 1 is negative 2. X to the fourth divided by x is x cubed. Now we're hoping that you might have an idea what that looks like. X cubed looks like this. What's a negative 2x cubed going to do to my arms? It's going to switch them like that. Yep. So the end behavior model is going to go like this. Now, what that tells me is that this graph is going to shoot up on the left, and it's going to shoot down on the right. Will it do the same things in the middle that this graph will do? Not necessarily. Okay? This is called an end behavior model because this graph and this graph will behave the same way on the ends, on the right end and the left end. For both of these graphs, as x approaches negative infinity, which means I'm looking at the left arrow, f of x shoots up to infinity. And on both of the graphs, as I go out to the right arrow, which out this way, as x approaches infinity, f of x shoots down to negative infinity. So when they're asking for an end behavior model, they really are wanting this equation. This is kind of the graph that would help you picture what's going to happen. All right, last one I want to go over is number 49. Sketch the graph with the following properties. You're going to have to make this one big graph. They give you a bunch of properties, a bunch of limits. This says that as x approaches 1, if there's no plus or minus, that means you're approaching 1 from both sides. That f of x, or your y-coordinate, is going to get close to 2. So what that's telling me is that if x is close to 1, my y-coordinate is going to be close to 2. So up here, as x gets close to 1, y is going to get close to 2. I don't know exactly what's happening right at 1. It could be an open circle there. It could be a filled-in circle. They don't really tell us. But I know that on both sides of 1, my y-coordinates have to be up here around 2. Next. As x approaches 5, does that little minus mean to look it to the left of 5 or the right of 5? Left, like 4.999. So 2, 3, 4, 5. It says the y-coordinates go to infinity. So what that means is that there's probably an asymptote here, and to the left of 5, my y-coordinates shoot up to infinity. Let me make sure that copied right out of the book. Yep, this one says the same thing, but this one means to look to the right of 5. The y-coordinates go to infinity. So we're going to have another set of arrows shooting up like that. Any questions about that? X is approaching infinity, so this means go to which part of the graph? The right side, correct. X approaches infinity out that direction. F of x is going to approach negative 1. So let's say this is negative 1 here. Make some room here. So what that's saying is that as x gets really big, the y-coordinate is going to approach negative 1 out here. It may connect like this. They're kind of giving you some clues what the graph looks like, and then you're going to have to maybe make some connections, some guesses, and then check the back of the book. I know it's going to level off at negative 1. What is this telling me? Which side of negative 2 am I on? The right side shoots up. So if I'm at negative 2 here, to the right of negative 2, it's going to shoot up like that. Okay, you can finish that one on your own. So give those problems a try. You probably aren't going to spend a lot more time in class on them.